This is Module 16 on loops. So if you follow along with the textbook, we're going to be covering section 5.1 and 5.2, just the beginnings of one of 3 different types of loop structures that we'll find in C++. So to start, I want to motivate a little bit about why we would use loops in a programming language. We haven't had to actually do this before, but there's a whole class of programs or a whole class of problems, actually most problems, that would really require us to do this. So before I switch over to Visual Studio, imagine we try to write a program that is going to print out every number between 0 and 10. And certainly everything we've learned so far, we could do this pretty easily. So I'm just going to create a brand new project, and of course we'll use this going forward. I've got my source code. This is programming exercise 16. And it's pretty straightforward. If we want to print out all the numbers from 1 to 10, or from 0 to 10, we can just copy and paste. It's certainly not a very good technique probably, but it's the only one that we really know so far. So I'm going to go over and try to run this. And we get what we would expect. Okay, so that's nothing really new there. But if we continue on with this, and then I turn around and say, okay, well, I want you to do the same thing, but I want you to print out the first 100 numbers. Or I wanted you to print out the first 10,000 numbers. You can certainly see how this strategy really isn't going to work for us. We can't keep copying and pasting. We need to be able to repeat line after line in some sort of a loop structure. So before I even go over to looking at the syntax of the while loop, I want to look at this program and see, how can we take this line of code, this cout statement with a particular integer, and can we imagine actually repeating one line of code that looks exactly the same? Because if we look at this, what's different from every single line in this code is the number that we're printing out. And so we know that we've got variables that can hold numbers, and the numbers can change. So before I even do this, or before I even go into the syntax of the while loop, what I want to do is just modify this program just a bit. I'm going to create a variable and start it with 0. And instead of cout 0, instead of cout 1, 2, 3, I'm going to cout x 10 times. And obviously, if we run this, we're not going to get the desired result just yet. It's just going to come out as 0. But we know we can also just do x plus plus. And the reason I want to go ahead and change this code right now is this is going to be a lot similar to what we're going to do with our while loops. I've rearranged the code. It's slightly longer now, but I've rearranged the code such that to print out the first 10 numbers, I'm literally executing the same exact line of C++ or a set of lines of C++ code each and every time. And I got the same result as last time. I think I need to add one more printout here. That's it. So how are we going to take a whole bunch of statements, or two statements in this case, that are exactly the same and I want to repeat them over and over again? Well, I'm going to use a while loop. And the syntax for a while loop is actually really familiar. It looks almost identical to an if statement. So if we imagine this keyword right here just being an if statement, we know that when this Boolean expression is true, we're going to execute those statements. When it's false, we're going to drop down below. The only difference between an if statement and a while loop is that after we've executed the statements inside that loop, inside that group of code, we're going to go back up to the top and we're going to reevaluate the Boolean expression. And what we're going to have to point out as we go here is that certainly there's going to have to be something inside these statements. One of these statements is going to eventually have to make this Boolean expression false for us to be able to get out of our loop. Right? So otherwise we're just going to sit here over and over again and execute these statements. So if I go back to my code now, just looking at that syntax, what I'm going to do over here is I'm going to say, well, when do I want to stop? If I think about it, I'm going to have some sort of a Boolean expression. I want to keep repeating cout x, x++ over and over and over again until I've printed out all the numbers. So we have to think about, well, what is it? What exactly is going to tell us that we're done? And one possibility is just to say, while x is less than 11. While x is less than 11, so it starts at 0, I'm going to print out 0. I'm going to do x++, and that's going to become 1. I'm going to keep going around this loop over and over and over again until x becomes 10. I print out 10, and x++ brings x to 11. And at that point, this while loop will stop. Right? We'll go right up to the top of that loop. 11 won't be less than 11, so this statement will be false, and we'll break out of that loop. And so we can see the exact same printout as we wanted originally up here. We've got now with our while loop without having nearly as much code. And certainly a much better solution. And obviously, if we want to do this 10,000 times, there's only one change, right? We don't have to keep copying and pasting anything. We can run this and it'll print out 10,000 numbers. It'll take some time, but it'll eventually get there. All right, so I want to practice a couple of these and just make sure that if you kind of think through and understand what these things are going to end up printing out, we can start moving forward and actually doing some real programs using these loops. So I'm going to grab maybe the first one over here, just so I can mark it up a little bit. Switch over here. And so let's just imagine this code starting to execute. And we can think about in memory, we've got a variable called x. It starts out with 3 in it. And we're going to enter into our while loop. Yellow's, I guess, not a great color. We're going to enter into our while loop, and certainly x equal 3 is less than 5. So we're going to enter into the loop and print out 3. Right? X plus equals 1 is just going to increment x. Okay, so we're right here. Once we hit that, and switch over to another color here. Once we reach this x plus equals 1, we're going to go right back up to the while loop. We're going to check whether or not 4 is less than 5. Yes, certainly it is. I'm going to print out 4. I'm going to get the x plus equals 1. Now I've got it at 5. I'm going to go right back up around to this while loop again. And now 5 is not less than 5, so the while loop stops. And so our final printout, will just be up there. So let's do one of these. You can kind of walk through this on your own. This is essentially the same type of an exercise. What these bottom ones are sort of illustrating is that we're not limited to just having one variable at play. So I want to look particularly at this and make sure that we understand exactly what's going to go on with this loop. And let me wipe this out. So again, we'll start out with our variables. We've got x, we've got y. Y is at 2, x is at 2. We enter into our while loop. X is certainly less than 5. We print out x. There's our printout. But now notice that we're just doing a y plus equals 1. Right? So that's important because at this point, y is going to change. But notice nothing is happening with x. So by the time, when we go right around this loop again, we're going to make the same check. And of course, x was 2. It is still 2. And we're going to print out 2. And if we kind of carry on this logic, as we keep incrementing y, we're not really getting any closer to that while loop stopping. So this is an example of what would be called an infinite loop. Right? So an infinite loop is a loop where we get inside the loop and we don't actually do anything to make that Boolean expression controlling the while loop false. So what's really critical is that we always remember when we're designing a loop, this Boolean expression has to become false at some point once we enter into this while loop. Having something like this, x equals 10 out here, isn't going to do us any good, right? Because once we go into that while loop, we're never going to get outside that while loop. We're never going to get outside these braces unless something inside these braces causes this Boolean expression to be false. Right? So this is just going to keep going and going and going, and we'll have an infinite loop. Now that's not to say that anytime you've got two variables you're going to have trouble, you're going to have an infinite loop. It's just to say that you need to be careful about it. So we can switch back over and look at the other example right, over here. And here we don't have quite the same problem, right? Because at this point, and again, we'll bring it over. When we look at this example, we still start with, oops. We're still going to start with our variables that we had before. Initialize things a little bit differently. We've got x less than 5. Certainly x is 2, so we're okay with that. We're going to have our cout of y. We're going to print out 10. Y plus equals 1. X plus equals 1. And now we go back around that loop. So again, the key point here, the difference between the last version or the last example and this one is that our x is actually changing. We don't have to print out x. There's nothing that says we have to use x or whatever variables involved in this while loop. There's no rule that says we need to print that value out. There's no rule that says that that value or that variable has to be involved in a calculation. We can use it for nothing more than just sort of counting around the loop. As long as we make sure that x is going to be eventually equal or greater than 5, this loop will stop. Right? So if this loop is going to go around a few more times and we're going to continue to print out y values until that loop stops. So let's continue on. And I want to go through a couple more examples here. So we'll start out with a new example, number 16, a counting loop or counting with a while loop. I want to add a little bit of a variation on this in that I want to let the user actually enter an integer between 1 and 100 and then print out every even number. So just the even numbers, including the number that they entered in. So this is what will eventually get posted as programming example 16. So what I usually do when I'm designing loops and when I'm thinking about any of these programs is I forget about the issue of even numbers for a second. And I just think about letting the user type in a number between 1 and 100. And I'm not going to do much input validation just yet, but I'm just going to grab a number from the user. And I'm going to make sure that my loop counts up and prints out values up to and including the number that the user types in. And then I'll worry about dealing with the even numbers, and we'll look at different ways of solving that problem. So I'm going to have some input from the user. Let's start fresh. I'll get that input, I'll prompt them. I think I said 1 and 100. And now I want to write a while loop that'll go around until input becomes, or until I print out a number that is greater than or equal to input. So one of the first things that we want to recognize is that the thing that's going to control our while loop, maybe it's x. While x is less than input, I'm going to keep going around this loop, and I'm going to print out some value x. The value x is really just a counter. Right? So if I look at this x value, this counter, I'm going to have to declare that. I'll start that at some value, perhaps 0. We're always going to have some sort of a counter and a limit. In this case, the user's actually entered the limit. I've asked them to enter a number between 1 and 100. I'm going to print out all the numbers, eventually all the even numbers up to and including the number the user typed in. So this is our limit. So a lot of times our while loops will be constructed as counting loops. And the counting loop is going to have a distinct counter. Perhaps it'll start at 0. It could start at something else. And it's going to have some sort of a limit. And it'll typically be designed like this. It could be going the other way. We could be counting down. We could be counting up. Either way. Each time around this loop, I've got to make sure that I increment my counter. So as x starts at 0, I'm going to print out x as long as x does not become equal to input. And then maybe I can print out some message at the end. So we'll build that. Please enter a number. Let's say I enter 12. I see 0, 1, 2, 3, 4, all the way out to 11. Now notice we don't really have it quite right? So one of the things that the program or the assignment said is print out every number, and eventually we'll deal with even, up to and including the number they enter. If we look at this, it's kind of strange. We don't see the number that we're looking for. We don't want to stop. We want it to stop with 12. We're only stopping with 11. So what we need to keep in mind is that this increment is actually happening before or after the printout. So if I look at these two side by side, we can sort of imagine that the code's going to print out the 11, increment, so x will become 12. The user's typed in 12, and then the while loop will stop. If we just switch them, we're not going to really get what we want. That won't solve our problem. It'll change it just a bit, because now we're going to start with 1 instead of 0. And that's not what we were looking for. So best way to handle this is to just sort of address it in the limit. While x is less than or equal to 12, or less than or equal to the input, I'm going to continue going around that loop, and I'm going to continue printing out the values. So now I can see 0 through 12. So our next issue is we want to print out. We've got the maximum number right, so our while loop is stopping at the correct time. Now I want to make sure that I only print out the even numbers. And so I've got a number of possibilities here, and let's just kind of write them all down. I could actually count by 2. right? I could start at 0 and then increment by 2, so x would be 0, 2, 4, 6, 8. Or I could selectively print only even numbers. Either way would give us the right result. Right? I'm going to start with the second one first, and then we'll just evaluate the difference. So how would I selectively print out only the even numbers of x? Well, I can say if x mod 2 is equal to 0. If x mod 2 is equal to 0, what I know about x is that it's even, and I'll print it. Now, what I want to point out here is that I do not include that x++ in that if statement. So let me run this and let's show what happens if I don't do that, if I actually put that x++ in the if statement afterwards. So right off the bat, that answer is working. That looks good. Let's just look at what happens if I put the x++ in here as well. It's an easy mistake. So what we have here is seemingly our program has just sort of crashed, or it's not doing anything. It's actually doing quite a bit. We've entered into an infinite loop, and the issue here is that when x starts at 0, we go into the loop. X mod 2 is equal to 0. 0 mod 2 is equal to 0. That's fine. We're going to do a C out, and we're going to print out the 0. Right? Out comes a 0. Then we do an x++, so x is 1. At this point, x with x is 1 will go into the loop. 1 mod 2 is not equal to 0, and we end up right here. And we're going to continue around this while loop indefinitely now, and that's why we're seeing nothing really happen. We're just busily walking back and forth through this while loop. Whenever you've got something like this happen, Control-C, hitting Control and then C will kill the program. And by doing some printouts, you can sort of show yourself, and it can be something really simple. You can prove to yourself that there's an infinite loop. And we can see here coming out forever. So it's important that, yes, we're only going to print if it's even, but no matter what, we're going to continue. So the values of x with this loop is 0, 1, 2, 3, 4, 5, all the way up to 12, but we're only printing it out when it's even. So that would be option number 2. Option number 1 is to count by 2. So we could do something like this. Now that solution is really nice. Our increment is a little bit non-standard, but that's certainly something we should be okay with. The benefit of this is that, well, yes, there's a little bit less to mess up, but also that we're actually really only going around this loop 6 times. So if this was a larger problem, if we were going to print out the first 100,000 numbers, it is more efficient to just actually loop through or go around this loop 50,000 times instead of 100,000 times. We should always try to check with some unexpected numbers. This isn't that unexpected, but maybe like a 13, an odd number. Make sure that our while loop does stop at the right time, and we've got it there. So that's an example of a counting loop. Counting up by evens, I can count up by odd numbers as well by starting with 1. And that's a very, very common type of a problem where we've got a counter variable and a limit that allows us to count up or count down to tell when we're going to stop. I'd like to go through one more example here and show you a different type of loop, which it kind of sounds similar, but really has a much different style or a much different strategy for attacking it. So example number 17, ask the user to enter 5 numbers that are divisible by 3 and 5. Don't let them stop until they entered 5 of them. So this is important because we notice that, first off, this is not a counting loop. I don't know how many numbers the user might type in. I'm asking them to type in a series of numbers fitting a particular criteria. I'm asking them to enter numbers that are divisible by two different things, 3 and 5. I certainly know how to read in a number from a user and determine whether they're divisible by 3 and 5. But I don't know whether the user is going to necessarily type 5 numbers that are perfect. The user might actually type hundreds of numbers that are not divisible by 3 or not divisible by 5. So in this situation, I need to keep track of every number that's fitting the criteria. Once I've got enough numbers that fit the criteria, once I've got 5 numbers, then I'm good to go. Then I can actually just go and stop that loop. So we need to design this program such that while we loop in and we grab a number from the user, our first thing that we need to do is determine whether it's a valid number, whether it fits our criteria, and then increment some sort of counter, all right, and stop our loop based on that counter. So I'm going to create this in a new project. And before I really even worry about a loop, I'm going to write a small program to do most of this work. Namely, I'm going to write a program that will read in a number from a user and just tell them whether or not it's divisible by 3 and 5. We want to make sure that we can figure out, first off, whether the number fits a criteria. So we've got our input. And now we've got to actually determine whether this thing is divisible by these numbers. So I can say if input mod 3 equals 0 and input mod 5 equals 0. And for this initial version, I'll just print out yes or no. Then we'll leave it at that. Okay, so I'll enter in, let's say 21. That should get a no. 30 should be divisible by 5 and 3. Yes, it is. 15 should be divisible by 5 and 3. Okay, so we're looking good. Once we've got a program that works once we're able to read in a number, determine whether it fits the criteria, we've got the code that wants to be repeated. Right, so at this point, we're almost highlighting most of our program here. It's this code that needs to be repeated until the user's entered a fifth number, at least 5 numbers, to print out yes. So first off, I have a counter. We'll start it at 0, and every single time they get a correct number, I'm going to increment my count. And if I look at this now, all of that code is going to continue to be executed while count is less than 5. And just like with if statements, with loops, it's really critical to make sure that your indentation is lining up nicely. Everything is nicely formatted. So please don't forget the importance of that. Having statements kind of floating around all over the place, it can make it difficult to see which parts are part of a loop and which aren't, which can lead to quite a number of bugs. So I answer a couple that are not correct. I'll enter 15, 45. These are yeses. 60, 120, and that was my fifth number. And I can add some extra stuff here. I can maybe add a little bit better of a printout. Maybe just say no, that doesn't fit the criteria. Perhaps we can say 5 minus count. And we can make it a little bit more user-friendly. And we could probably write an if statement to get rid of that 0 there as well.